Hello everyone. Today I want to show you how to move the functions up and down. So first I want to start with the example of our favorite quadratic function, the parabola. And we will move to other functions as well because they all move in exactly the same way. So here's our lovely quadratic function, and the reason I'm using this as my first example, it has this wonderful point over here, which is the vertex. And in its most basic form, which is what we would call the parent function, it lands on 0, 0. So because it lands on 0, 0, it would be very easy for us to track where we move this function. So let's start moving it. So let's say I want to move it up. So I'm going to go ahead and move it up by, say, 3. All I have to do was add 3 to my parent function. So here's plus 3. And now you can see that my parabola is up here. So it's now shifted up by 3 units. So the rule of thumb is if you're adding a number, a constant, you're moving it up by 3. So what if I want to move it down? Right, so here's my parent function again. Well, very simple. I just subtract 3. And now I moved it down. So I said that any function can do that, right? So what if I have a rational function? Y equals 1 over x. Will this work the same way? Yeah, absolutely. But the thing with this function is it doesn't have this useful point, right? It actually doesn't have anything at point 0, 0. But we do have a couple of useful points at 1, 1 and -1, -1. So these are the points where the wings of our hyperbola, right, because that's what this function is, are closest to each other, right? So you can see them at the end of the squares over here. So let's see. So let's say I want to move this up by 3. I add 3, and bam, it moved over here. Now, how far did this point move? Well, it was at 1, 1. So it should be at 1, 4, because I moved it up. When I move it up, I only change the y value. So when I trace this out, and this point is in fact 1, 4, because I added 3 to every single y value, right? So it's at 1, 4. Excellent. What about some other function? What about some exponentials? Why ever not? Here's a lovely 2 to the x. Once again, we don't have a nice point at 0, 0, but we do have a really nice point at 0, 1. This is our y-intercept. So if I add a 3 to this function, I will shift everything by 3, and this point will be at 0, 4. Well, let's take a look. There it is. What if I shift it down? Well, if I shift this down, I'm going to go 1, 2, 3, so I should be somewhere at -2. So minus 3, 0, -2. So you get the idea, right? You can always figure out by how much you shifted by choosing your reference point. Or you can look at the equation and look at your constant. The constant is always how much you're shifting up and down. So this is shifting up and down. What about going sideways, left and right? Well, to do that, let's get back to our parent function. Here it is. This is how you do this. You're going to put your x in parentheses. This is important. Now, right now, it sounds completely silly, right? Because it's just x by itself in the parentheses. But if you add or subtract a number in the parentheses, magic will happen. But there is a wrinkle. Turns out that when you move it right and left, it's the opposite of what it should be. And this is what I mean. When we moved up and down, you moved this whole function up, you added a number. So you moved in the positive direction by adding positive numbers, right? By adding numbers. Well, in this case, you move in the positive direction by subtracting numbers. So when I'm going to shift it on the x-axis, I literally will be subtracting numbers. So here's 1, x minus 3. And yeah, I moved to the right. So when you are on the x-axis, it's inverted. And it does work exactly the same for all the functions. So here is example for a rational function. So here is our rational function that is a parent function. Once again, you put your x in the parentheses down there, and then you add or subtract a number. So since I subtracted a number since I moved my parabola to the right, I'm going to go ahead and move this to the left. So I'm going to go ahead and add a number. And you can see I have shifted it over by 3. This point, my reference point, it was over here at 1, 1. And it literally went 1, 2, 3 to the left. And this works for any function, right? So we tried an exponential last time. This time, let's do a logarithm. How about log of x? And yeah, I can do that. Put your x in the parentheses. And then add or subtract. And it's the inverse of what you want. So it's plus. How about we do a plus 4? There we go. Moved it up. Moved it to the side by 4. To the left. All right. So, next question. Well, can we do it all at once? Yeah, for sure, right? So here's a lovely parabola again. So x squared. Well, I'm going to go ahead and move it to the side by, let's say 2 to the right. And then I'm going to go ahead and move it up by 1. And there you have it. Both of them. I can do the same thing with my log, for example. So this one is already shifted to the left by 4. How about I move it down by 1? There you go. Very, very, very straightforward. And you can do this to any